Hello, everyone. My name is Husseini, and I'm going to talk about BPE or Byte-Pair Encoding, which is actually used for tokenization in large language model. Uh, I'm going to talk about a little bit about that, why BPE is used, the difference between character level tokenization, word level tokenization, going through an example of using BPE, and then we're going to go through code provided by Hugging Face. We'll see that how we can apply BPE using coding in Python. All right, so a few things that I have in here. Let's just start with this. So BPE, which is byte-pair encoding. So we know that large language model, basically what they do, that they predict the next word or next token, but actually how they apply token. So let's just start if we use the character base. It means that we use the character, all the character to tokenize. So let's talk about if you're using English. So if I use character base, it means that in English I'm going to use all alphabet. So we have A, B, C, D, so on. We use the uppercase. And we might have some special character like period, exclamation, question mark, and so on. So you can think of maybe roughly 60, 70 characters, which is fine. So let's see that we have a sentence in here. I love cats, for instance, and we wanted to tokenize them based on character-based level. So so I have I love cats. So each one we consider as a token. So I have I would be one token. Actually, we have a space in here. You would consider that a space, another token. So let's ignore that for now. One token, 2, 3, 4, 5, 6, 7, 8, 9, and period is 10 token. So we have 10 tokens in here for this sentence. Okay. And now imagine you're writing to ChatGPT with a paragraph. You're writing a paragraph in ChatGPT. So paragraph, imagine, has about 200 words. And each word has roughly 5 characters. So in total, you might have over 1,000 characters or 1,000 tokens. So ChatGPT, I think it has 128. Can take the input as in prompt. Some of them were 32K. But there are some open source, for instance, they take the input of 2048 tokens. So you have one paragraph. I get the majority of tokens with that only one paragraph. So compare with 1048 tokens. So it actually takes a lot of memory in that case. So this is the issue why character base is not used. So now you can think of that, why we don't use words. So the same thing, I can use word, and I'm gonna just remove that space. I can use words instead of character base. I'm gonna remove this. Why don't we start with words? So I can do that. So each word And again, we're talking about English. The idea is exactly the same thing for other languages. So I can use words. So each word would be one token. So this is one token. This is another token. And cats would be another token. So first of all, you need to consider how many words that you have, so that each one of them would be a token. How many words that we have that in English, and each one of a token, so that would be huge. So comparing with this one, using word-based tokenizer would be a lot. First of all, it's a lot better than character-based because of how many tokens that it takes. So this is 3 tokens in here. We had 10 tokens in character-based. So it's a lot less. But in order to do that, you have to, every word in English need to be tokenized. So we'll see that how many words that we have only for English. And what happens if you have a new word? You have a new word, or we out of vocabulary. So with this way, it actually doesn't recognize that the new word. And so when it doesn't recognize, how can it predict the word that is not in its vocabulary? So it's caused an issue with that. So the middle ground here is using BPE, Byte-Pair Encoding. And let's see how this Byte-Pair Encoding works. So let me remove the whole thing. I'm going to go through Byte-Pair Encoding. Okay, so in Byte-Pair Encoding, or BPE, we have few steps, and I'm going to go through an example how we use that. So the steps to create Byte-Pair encoding is few steps. First, you start with a corpus. So corpus would be collection of words based on your documents. Could be a paragraph. It could be like the whole words that document that you collect that from the web. Then you initialize your vocabulary. So basically, what you do that in here, break the words to individual characters. So all alphabets. Third step is you split the corpus. You split the corpus, so basically you represent each word as a sequence of those base or initial vocabulary, just all alphabet that you create. Next step, you're going to count pairs. What do you do that? So you basically identify all consecutive token pairs in the corpus that you have. And then you're going to count them. Next, you actually merge most frequent pairs. So calculate pairs, and you are going to merge the most frequent ones, and we'll see that how each step works. And when you merge that, you actually you update your corpus. So your corpus doesn't need to be in character level anymore. It could use the merge one based on the most frequent pairs, and you update the corpus, and you actually keep doing that until you get to the level of how many vocabulary you actually use that. So for instance, uh, uh, tick token library uh, uh, created by OpenAI, for GPT-2 tokenizer. It has about 50,000 tokens. So let's look into that. These are steps in an example how it works. So let's just start. So imagine we have start with our corpus. So imagine we have um, you have a corpus with bunch of words, and we have the frequency. So in your corpus, whatever your corpus is, uh, a bunch of text in your paragraph, and you actually, so imagine in that corpus, you have the words and you're going to count them. You have cat, it actually happens 8 times. You have bat, uh, happens 6 times. That's the frequency in that corpus was. You have cab, happens 4 times, and you have cats, not cats. You have cats. It's happened 3 times. So this is our corpus. So what we're going to do that in our first step, we're going to initialize our vocabulary, which is our base vocabulary, which we actually, we do that, we create that in our, based on character level. So basically, you calculate, you find out your base vocabulary, which is character level. So in this case, we have C in here, we have C on character, we have A, we have T, we have B here. So all the unique characters you're gonna create that. We have, and we have S here. Yeah, that's all we have. Now, you are actually, you're gonna create a corpus based on, so not the words anymore, and you're gonna create them based on this base vocabulary. So now, so we had cat 8 times. So this cat would be based on my initial or base vocabulary. So that I have C, I have A, I have T, which happens 8 times. Happen 8 times. Now the next word is B. I have A, T. This happens 6 times. Same thing. I have C, A, B for cab. This happened 4 times. And the last one is cats. So I'm going to write it down here. I have C, I have A, I have T, and I have S. This happened 3 times. Now, so we're going to count the frequency based on that. Next step, which is our step 2, we're going to count the frequency. Count the pair frequency and find the one with the maximum frequencies. So let's look into that. So you're going to pair them. So the consecutive characters in here, you're going to pair them. So we have CA here. CA here. So I have CA. From here, this happened 8 times. And also this CA, so let's do that this way. This color actually is not good. So I have CA. Well, let's pair each consecutive character. So I have CA. This is CA. It happens 8 times in here. I have CA in here. It happens 4 times in here. And also I have CA in here. It happened 3 times. So in total, it happens 15 times. Now let's look into another pair. So that's AT. AT happens 8 times in here. It happens 6 times in here. You don't have in here, and 3 times in here, which happens 17 times. Now, let's look into another pair. So we have BA in here. So I have BA. How many times happen? So I have 6 times in here. There's no BA, another BA in here. So this is 6 times. That's a final number. What else do we have? So we already calculate AT. We already calculate CA. We calculate, okay, so there's 2 pairs, we calculate that, these. And also we have AB in here. AB. What's the frequency? So we have 4 times in here. 4 times, there is no other frequency. So CA, we already done that. And here, we already calculate that. AT, we already done that. And do we have TS in here? That's another pair. So, and then we are going to calculate TS. How many times do we have for TS? That's only things that we have it 3 times. Okay. So what we're gonna do that, we're gonna find that. So based on this, we found out what's the most frequent pair, which is AT. It happened 17 times. So that's when you're gonna merge this AT. So instead of so from character level, we split the corpus. So wherever we have A and T together, instead of use them as character level, we merge them and we're going to use AT together. So now this is what we call a merging based on most frequent one. So now when we have that in here, we're going to go back to our corpus and we're going to update that. So because we have the merged most frequent pair. So if I go back to this one, when you have that in here, so I'm going to write it down again. So this is character level. So instead of this character level, we're going to have A and T as character level. I'm going to replace that with AT. The same thing in here. This would be replaced with AT. The same thing in here. So you see that we are going to reduce the size and we're not going to use character level anymore. So this is replace that. So this is what we have. So now we're going to keep repeating that until we get to the number of vocabs that we define that. So that's what you do that based on your need. Okay, so now let's see that what happened. So our updated corpus. So what happens to our updated corpus? So we had cats, but this is not character-based level. So we have the new token actually. So we have for cat, we have C with AT. If we merge that, which has happened 8 times, we have bat, which now is BAT, happens 6 times. We have cap, it actually wasn't part of the merge, any of these pairs. That happened 4 times. And we have cats. actually cat AT, the merge pair, we have S, and this happened 3 times. Now what we're gonna do that, we're gonna do that again. Count frequency, pair frequency, and we'll do that same thing. So let's do that to count frequency. Count pair frequencies. Count pair frequency. So this is based on our updated corpus. So pair frequency. So these two pair together. So we'll see that basically for C and AT. If we pair them, how many do we have that these pairs in total? So 8 times happens in here. I don't see that in here, nothing in here, nothing in here, but we can see that these two could be paired and 3 of them in here. So that happens 11 times. So this is one of them. Now, what's another pair? So these two could be paired. So I have B and I have AT, which comes back. It happens 6 times in here. Nothing in here, nothing in here, and nothing in here. So that's the total. Again, we start with this, 2 pairs with this CA. Look into our updated corpus. So this happens 4 times in here. Let's look into that. We have any other CA. Don't have anything. So this is AT. Nothing in here. Nothing in here and nothing in here. That's only 4 times. Same things, another pair that we have. This is AB. Happens 4 times in here. Nothing in other ones. So that's total 4. Now we're going to look into this one. So this 2 pairs, we already calculated that as part of in here, and these 2 could be paired. So we have AT and S. These are paired, and we only have ATS. We only have 3 of them. Nowhere else. So now what happened, we actually figured out the pair frequencies, and what I need to do that, find the most frequent one, and that's where you're going to merge them. So the new one would be cat. That's when we merge them, so we get cat. So now we're going to update our corpus again. So this is basically now would be merged. So instead of C and this would be cat. The same thing in here, these would be cat. No changes in here, and so on. So that's a merging. So basically everything that we have in here, so this would be converted that to the first one would be cat. Happened 8 times. We have bat with the AT. This happened 6 times. We had cap, the stolen character level. Sorry, that was 4 times. We had cats. We can use that. Okay, so this is our updated corpus. So we start with the character level. That's our initial vocabulary, and these are based on pair frequency. We calculate that. We find that. These are BPE, and you can keep doing that. So this would be our new token, and you could keep doing that based on how many vocabulary that you can create. And this is the process that you can keep doing that. And if you go that, for instance, based on number of vocabulary, if your vocabulary size is, for instance, 8, That's what you define. Your desired vocabulary size is just 8 tokens. If you keep doing that, for instance, your vocabulary would be like this. So you have A, B, C, S, T, A, T, cat, bat. So this is a token. You can have more. So basically, you keep merging them until you get to the vocabulary size that. So we start with the character level. So anytime you have anything like cat, it will use this token. So it actually reduces the size of memory and the number of tokens that you use. So which is very beneficial. So that's the whole idea of BPE, byte-pair encoding. That's how this process works. Um, let's look into the Python code actually from Hugging Face, and at the end I'm going to share that link in YouTube. Let's get to that file. I can't find that file. Okay, so this is byte-pair encoding tokenization by this code provided by Hugging Face, and it's going to use transformer. So let's see how it works. In order to use that, it has few libraries. We need to install that. And I'm going to use Google Colab. So imagine this is our corpus. So we have few sentences. This is the Hugging Face course. This chapter is about tokenization. This section shows several tokenizer algorithm. Hopefully you will be able to understand how they are trained and generate tokens. In order to do that, so they are actually, this is coming auto tokenizer is coming from transformer library by Hugging Face, and this is pre-trained based on GPT-2 model. We can actually look into that. What's a number of vocabulary actually this model actually used. So the total vocabulary size is 50,257. All right. So what is happening in here? First, you can use this this function actually give you the word frequency. So same thing that we had cat, bat, what's the frequency of each word within our corpus. So in this case, for instance, it will tell you that this, our corpus, it happened 3 times. So we have this 1, 2, 3. And it does that for every word. So for instance, so we have 1 in here, 2, nothing else. So it actually, what it does in here, in order to, when we have a space to separate words in here, we'll add another character, special character, just G dot. So it means that there's a space before that. So we'll see that. And also GTE or which is a space before that. It happens only 1 time. So I can go back to this corpus and we'll see that there's only 1 there. And there's nothing else. The same thing for hugging, and you can keep doing that. So we calculate this for first steps. We find out the word frequency between our corpus, and this is what this library do that pretty easily for you. Now, the next steps, we are building our initial character, initial vocabulary. So you can see that this is our initial vocabulary. This is just building in here based on our corpus. So this is all the vocabularies that we have. For instance, this is coming from up here. Uppercase H is coming from hugging, and this is all initial vocabulary. And actually in here at the end of text a special character to our initial vocabulary. So basically separating sentence if you need that. So now what we're going to do that this is what we build our corpus based on our initial vocabulary that you see that in here. So that's our starting point. So the word this based on initial vocabulary, it has T, and this is all character based or initial vocabulary. We have TH, IS. This is again a special character G.is. We're gonna create that, split them based on initial vocabulary. And we do that for every word. And that's what you see that. Now, what's our next step? So we build our corpus based on initial vocabulary. So we need to calculate pair frequency and merge them based on the most frequent one. So this is what it actually do that. It actually calculate the pair frequency, and we can find that the maximum pair frequency and update our corpus based on that. So this is what actually this part of the code doing that. And we here is going to look into the pair frequency. In this case, you just print out only 5 of them. It is a large list. So we see that, for instance, TH, there's 2 pair. It actually happened 3 times. HI happened 3 times. I is 5 times. And we can find that the maximum pair frequency, and we update our corpus based on that. So it's look like this G.T, so it's space before T happens 7 times. So we can use this maximum pair frequency to update our corpus. Yeah, so this is the part this part I actually use that to show the best pair with the maximum frequency, which is G.T. So it means that there's a space when we have a space, a space before T that happens 7 times. So that would be our maximum frequency, and we can use that to update our vocabulary. This is just showing that if we wanted to update our vocabulary, was at the beginning was just character based. This is when we can add that. This part of the code, it actually use that to merge pairs. So what I would use that. So we call that, it get 2 inputs. So for instance, what happened? We know that we started with character-based level. So imagine we have the most frequent one, and we're going to merge that to update our corpus. That's what exactly is doing that. So if you have 2 pairs, which is the most frequent one, and we're going to update our corpus, you pass those 2 pairs within and apply on a corpus. And for that words, for instance, it won't be character level anymore. And those pairs would be updated that. And it actually happens anywhere for our when we have GT. So I can look into my corpus. We basically update it. Let me run that before this. So if I look into my corpus after this is actually updated, I'll see that anytime I have G.T, they will be merged. So for instance, I have, G there. We'll see that this is updated. And any other place, G token as a G.tokenization, this is updated and so on. So anywhere they actually find that, this would be merged and so on. So, and this is the whole thing. So imagine in this case, I wanted to build my vocabulary size 50 times. So that's the step. You just keep doing that. The final vocabulary for a tokenization will generate 50 samples. So that's just every time, calculate the most frequent one and update our corpus, and we'll add it to our vocabulary. So that's what this steps doing that. You can actually look into the merges or finally our vocabulary. And this size would be 50. So we start with initial one, initial character base, and anything just paired. So that G.T, for instance, is a new one, and it keep doing that. This is another token for us based on P or G.token. So you can keep building that. If I'm looking to, so imagine I wanted to look into this vocab size. So that what's that size? So you get 50. So this is how they define. Um, this part, this is the whole thing together. Everything's together, which actually can do that. So this, if I call this function tokenize, this is not a token. It actually separate them based on the token. We build that based on a corpus. So this would be one token. G is another token. Space is G dot. And anything is already available. It's not going to do that using character-based level. So that G dot token, that's the whole thing, or G dot A. These two together. T wasn't part of our per frequency with OT, for instance, or not. So you can see that it depends on the size of your corpus that you see. That's what in ChatGPT or large language level. You just basically dump down a chunk of internet to build their tokenizer. So it's all depends on corpus that we have. So for instance, if I just want to do that, my name is Sohal Hosseini. Not everything is, we don't have a lot of things in our corpus, and corpus was a small. So any part that we built that based on or updated vocabulary will be built with those tokens. So for instance, SE was part of the token in G.is in here. Nothing more than the other one. And you can, again, you can build that, increase the number of vocab and add more documents. So this is the whole idea of byte-pair encoding. All right, thank you very much. I see you guys with another review next time.